grade 11s, so now the real fun part begins because we're now starting to mix these rules. So it's a little bit boring doing one at a time, but when we start mixing them, this is what exam type questions will look like, and this is the part we have to practice the most. Now we're only going to do 3 examples together because actually the key comes in being able to practice on your own in the exercises. So let's have a look at this first example. They've always read the instructions because sometimes in some diagrams it's hard for us to label small angles, and so often information is given in the blurb that's not drawn in the diagram. So in the figure below, PQ is 80, PS is 100, and SR is 110. And then we have an angle of 60 and an angle of 120 degrees. And the first question says determine the length of PR, which is in both triangles. So don't forget, I've said this before in previous videos, often when you're given 2 different triangles, they're linked by a common side, and that's the key because we use one triangle to find the connector and then we can use it in the next triangle. So if I just look here, there are 2 triangles that PR is in, but PSR is where I know a lot of information. And what information do I know? I know 2 sides and an included angle. And when you say that in your head, the alarm bell should go off, in that that's a classic cos rule type setup. I can't use the sine rule here because if I'm looking for a side using the sine rule, I have to know 2 angles. I have to have a given pair, and there's no given pair here. And so I'm going to set up the cos rule. And the cos rule says that PR squared would be 100 squared plus 110 squared minus 2 times 100 times 110 times cos of the angle in between those 2 sides. So you could now just write down what PR is. If you'd like to write down what PR squared is, it's 11,100, but there's nothing wrong in an exam with going straight to the answer. Now the answer in this case, if I do it to 2 decimal places, they didn't say simplest third form, so I'm going to do 2 decimal places. I get 105,36, and in this case millimeters. Now if we move on to the next question and we use PR in any form, so I actually tend to go and write that in on my diagram in case I need it. If I'm going to use PR, you're welcome to now use the rounded off version because it'll be a new question. So this question says determine the area of triangle PRS, which is that blue triangle, and in this case don't forget that area, this is not a right angle triangle, so I'm going to use the area rule, and the area rule says a half side times sine angle in between those 2 sides. So I can't use PR that I just found out because the angle that I'm using is 60. So I have to use the 2 sides that enclose that 60 degrees. So I get an area of 4,763,14 millimeters squared. And now if I move on, the question says determine the size of QPR, which is this angle there. Now actually in a test what they might do is just straight away ask you QPR, and then you have to know to first do PR to find the interconnecting side, because at the moment with what I was given I didn't have enough information in triangle QPR, so I had to first find PR, and now I can work with angle P. So an exam question, a good 5-6 mark exam question would be not to scaffold it for you, to not ask you question A but expect you to do question A to then do question C. Now, am I going to use the cos rule or the sine rule? Well, I have an angle and its opposite partner. So that would mean that I'm tending towards the sine rule. The only problem here is the other side I have is opposite angle R. So if I'm going to use the sine rule, I can find angle R. However, sum of angles in a triangle can get me to angle P. I can't use the cos rule here because to find an angle using the cos rule, you have to know all 3 sides. And I don't know all 3 sides here. So this has to be the sine rule. Now because I'm going to find angle R, I'm going to put sine of angle R at the top, and so divided by the side opposite it, and that'll be sine of 120, and you're welcome to use the rounded off version. So 105,36. So if I multiply by 80 on both sides, I get sine of angle R is equal to 0,6575 blah 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 blah. Now I use my answer button, so I would go shift sign of answer so that I don't have to worry about all the decimals. So I get angle R is 41,115 degrees. Now it doesn't really matter if I round off here because all I'm going to do is sum of angles in a triangle, and so the rounding won't be affected in the future. Now, don't forget that a sine equation technically has two answers. However, look at angle R. Angle R has to be acute because the other angle in the triangle is 120. So simply because R has to be acute, I don't have to bother finding the second answer as 180 minus 41 because it's not possible in this situation. So now, to find QPR, I do 180 degrees minus the 120 minus the 41.115, and I get 18,88 degrees. And don't forget, that needs the reason. And my reason is sum of angles in the triangle. Now, this was a past paper question, so this is exactly what you could possibly get. This would be considered a fairly easy one because each question only needed one calculation. So as I said, a more difficult question would be to ask you to find this QPR but not give you any direction. And the key there is if two triangles are connected by a common side, that's your key. So let's look at another one. In the diagram below, AB is 3 centimeters, that's been labeled. Angle B is 120, BC is 5 centimeters, DC is 8, and I've got 81.8 degrees. And it says find the size of angle D. Now that's up top there. Now this is a classic good example of a past paper question, because why have they given me two triangles? They've given me two triangles because these triangles are connected by a side, and that's going to be the key here. Because if you look at my top triangle, which is DAC, at the moment all I have is one angle and one side. I have no other information, which means I can't use normal trig, it's not right angled. I can't use the cos rule or the sine rule because I don't have enough information as of yet. However, in the other triangle, I have two sides and an included angle. And the moment I say those words, you should think cos rule. Two sides and the included angle can help you find the third side. And the third side is the connector into the next triangle. So very common kind of pattern. So I'm going to try and find AC using the cos rule. So AC squared would be equal to 3 squared plus 5 squared minus 2 times 3 times 5 times cos angle in between, which is 120 degrees. So I get an AC squared value of 49 because all I did is worked out the entire right hand side. And then when I square root, I get 7 centimeters, which is quite a nice whole number. So if this is 7 centimeters, I can now work in my top triangle. So in my top triangle, you'll now notice that the 7 is directly opposite the angle I want, and I have a partnering pair of 81.8 and 8 centimeters. So I'm thinking the sine rule. So if I'm going to find out the angle at D, I'm going to put sine at the top, so sine of angle D divided by its opposite partner. Now that will be equal to the sine of 81.8 degrees all over its partner, which is 8. So if I multiply by 7 on both sides, I get the fact that sine angle D is equal to 0,86605 blah blah blah. Now I just keep that on my calculator and I do shift sine, and I get an acute angle of exactly 60 degrees rounded to 2 decimal places. Now, should I worry about going to do the 180 minus? Absolutely not, because this is an acute angle and it has to be smaller than the 81. I know that because the 81 is opposite 8 centimeters, and the bigger the angle, the bigger the side opposite it. So if this is 7 centimeters, which is opposite D, D has to be smaller than 81 degrees, and so this makes sense. So that's a very good example of an exam question. And what's quite nice with these 2D trig examples is that you're going to notice they tend to follow the same pattern every time. Two triangles and connected by a common side. Okay, let's try one last one. In the diagram, the circle passes through P, Q, R, and T. So just so you know that means that this is a cyclic quadrilateral because all four of those are on the circumference of the circle. We've got 7 centimeters, 8 centimeters, and 9 centimeters, and RQT, which as you can see is not labeled in because it was too small, this is 37.5 degrees. So always read the blurb. First question says, determine the following. Angle P. So angle P is in a triangle, and it is in a triangle where you know all three sides. And if you know all three sides of a triangle, that's a classic cos rule. Now, notice that the angle is between 7 and 8 centimeters. So I'm going to say that 9 squared is equal to 7 squared plus 8 squared minus 2 times 7 times 8 times cos angle in between 7 and 8, which is P. So that's why the 7 and 8 had to be on the right hand side, because they're the ones that sandwich the angle of P. Now 9 squared is 81, and 7 squared plus 8 squared I can work out because those are just numbers, they're not attached to anything else. So those two together are 113. However, 2 times 7 times 8 is attached to the cos P. So you can't say 113 minus 112, because that 112 is attached to cos P. So most people make the mistake here because they do 113 minus 112 and they get 1 cos P. And so then they get cos P equaling 81, which we know is never possible because cos can't be bigger than 1. So if you're getting a situation like that and you're doing shift cos and it says it doesn't exist, it's because you've made kind of a basic arithmetic error. So just be careful that those are different terms and the 112 is attached to cos P. So now I can minus 113 on both sides, so I get minus 32 equals minus 112 times cos P, so I just minus 113. And now when I divide by that 112 on both sides, I get 2 over 7 is equal to cos P. Now I've said this before, these ones are great because when you shift cos, you don't even have to worry about a second solution because the second solution would not be possible in a triangle. So I get 73,398, so 73,40, and I always go and fill it in because it could help me. Right, so let's look at the next one. The next one is angle R. Now angle R is in a triangle. It's in a triangle with, I know the side opposite it because the side opposite is 9, so that looks good. But I don't know anything else in the triangle except for the angle of 37.5, so I just don't know enough information. I don't see any right angle triangles, and so sometimes this would be quite a sticky one to think about. However, notice that this is what we call a cyclic quad. So I said that in the beginning on purpose because do we know that opposite angles of a cyclic quad add to 180? So angle R is equal to 180 degrees minus 73,40, and this is probably going back to last year, so a little bit rusty probably, but our reason is opposite angles of cyclic quad. Now it's quite common for them to start bringing in other sections here, and so this is something we're going to need to get used to. However, we're going to practice geometry and do the whole section of geometry, and so we will get better. So I get 106,6 degrees for the angle of R. Now don't forget that in exams often a question leads to the next question, so if you've just found P, try and remember that that could be a stepping stone, which it was here. Right, so let me write that in. So that's 106,6 because you never know if we'll need it. Now the next question says the area of PQT. Now PQT is the top triangle, and that's fairly easy because we were given the two sides and the included angle. So the area is a half side times side. I suppose we weren't given the angle, but we found the angle. The angle was 73,4. And you can use the rounded off version because this is a new question. So that equals 26,83, and this will be centimeters squared. Right, and our final question is the length of RT. So if I stroll up, where is RT? Well, RT is in this triangle, and immediately I notice that I now have a pair. Because I worked out the size of angle R, I have a pair in angle R and the 9 centimeters, and RT is opposite to 37.5. And so I can set up the sine rule. So my sine rule will be that RT divided by the sine, and the angle opposite RT you'll see is 37.5, so 37,5. Now that will be equal to 9 centimeters divided by sine, and I think it was 106,6. I'll scroll up and check. 106.6, absolutely. Notice I put the side length at the top because that's what I was solving for. So if I multiply by sine of 37.5, I get 5,717, so 5,72 centimeters. Now again, always just look whether that's possible. Could this be 5.72 centimeters? Well, opposite 106, which is definitely the biggest side of the triangle, is 9 centimeters. So this is much smaller than 106 degrees, the 37.5. So opposite the 37.5 should be a much smaller side. So that does make sense. Right, and so that's the beginning of us starting to mix the rules. The more you practice with these, the more quickly you start recognizing which of the rules make sense for you. So just to summarize, there were no right angle triangles in these questions. We are going to move into the next topic, which uses a lot of right angle triangles. And so always ask yourself, is there a right angle triangle? Then check, is the sign rule useful? And is the card rule useful?